Okay, students, so we're here in Unit 5, and if it just so happens that your favorite shape is a triangle, you're in good luck. Why? Because this unit's called Unit 5, Triangles and Their Properties. So we're just going to spend a whole unit talking about triangles, things that exist within a triangle, why triangles are so cool, so on and so forth. And really, why are triangles so great? Why do they get their own unit? Well, just really quick, some chicken scratch is like, well, I can take two triangles and bash them together. I don't know if that works. And then you get a square. Or like a pentagon is just three triangles stacked on each other. All right, so all other polygon shapes with only straight lines, it's just really a composition of triangles. They're all constructed from triangles, they're all made from triangles. Thus, we find out and figure out a lot of things about triangles, and then we can apply them to other shapes. And that's why we know things about shapes. All right, and to me, it's pretty important to know things about shapes. Why? Because buildings are built out of shapes, and we want to ensure that our buildings are built so they won't fall on our heads, because that sounds like it would hurt a lot. Anywho, that's enough. These units largely follow Unit 5 iBook. All right, the page numbers are a little off. That means someone's just updated the iBook. But you can turn this video off and just read the iBook. That's cool. So you can just do the iBook. Or if you love the sound of my voice and think I do a really good job, you can stay on this video and watch them. All right. So the triangle sum theorem, the sum of the interior angles of any triangles is 180 degrees, exclamation point. All right. Triangles add up to 180. Now, that means that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Now, how do we know this is true for any triangle that has ever existed? All right. How do we know that this is true for any triangle that has ever existed or that will exist in the future? Well, we have a proof. All right. We can prove this to be true. And this picture right here is one of the most powerful pictures in the universe. It's more important to our history than the Mona Lisa or any other kind of pictures. Why? Because we use this picture to prove that triangles add up to 180. And thus we have all the constructions and buildings that we have today, all the architecture and engineering. So if it wasn't for this picture, we'd still be living in caves. So you can thank the ancient Greeks for this one. All right. So we're given that triangle ABC. We're given this triangle, and we have these two parallel lines here. Why are these parallel lines? Well, stay tuned and find out. All right, so first is always given. Now, realize we have these parallel lines. I'm just extending them right now. And since I'm extending them, well, we can look at angle 1 and angle 4 are alternate interior angles. Or, similarly, if I focus on these parallel lines, and this time I'm going to use this as a transversal, AB as a transversal, well, holy cow, 2 and 5 are also alternate interior angles, all right? They're just alternate interior angles by definition of alternate interior angles. All right, and thus we know that they are congruent by the alternate interior angles theorem. And thus, since the angles are congruent, we know that they have equal measures. We haven't seen this in a while, but it's still the same thing, just definition of congruence. Since the angles themselves are the same, so will their angle measures. So however many degrees they are. Now, look at this. This is written a little quirky, still true nonetheless. Angle 4 and angle CAD. All right, I can call this angle 4, and then angle CAD is this angle right here. All right, so what are these blue angles forming? Well, they're forming a linear pair by definition of linear pair. All right. Also, kind of going quirky, followed the iBook on this one, but let's talk about 7. We can put 6 on pause. Remember, there's not always a specific way two column proofs have to go. Sometimes they can flow a little differently. Well, angle 4 and angle CAD are a linear pair, so angle 4 and angle CAD are supplementary by the linear pair postulate. All right, we use that buzzwords. We had the buzzwords linear pair, so I'm going to use it again. And thus, since they're supplementary, again, we're skipping 6 for now. We know that angle 4 and angle CAD add up to 180 by definition of supplementary. So again, using the buzzword from before. It said that they were supplementary, so we know that they add up to 180 degrees by definition of supplementary. All right, now let's roll back to 6. I want to do 6 now. I'm finally ready. Now look at angle CAD. Angle CAD, angle CAD, is specifically angle 5 and angle 3. All right, angle 3 and angle 5 combined to equal angle CAD. All right, angle, we haven't seen this one in a long time. Angle addition postulate. All right, angle, it's mathematically legal. I can say the measure of angle 5 plus the measure of angle 3 equals the bigger angle by the angle addition postulate. All right, so now notice how measure of angle 5 plus the measure of angle 3 equals CAD. So when I see CAD there, I'm just going to substitute it in. All right, so that was legal. Sob, sta, to, Sean, cool beans. Now lastly, look at this, super close to being done. Measure of, oops, I thought I was in highlighter mode. That's so embarrassing. Measure of angle 1 equals the measure of angle 4. So 4 got replaced with 1. Measure of angle 2 equals the measure of angle 5. So 5 got replaced with 2. So all I did was a massive case of substitution again. All right, so this was a 2-column proof. All right, basically you just take a triangle and make one side parallel to the opposite side. And then you can use this logic and reason that prove that any triangle drawn in the past, any triangle that currently exists today, or a triangle that will be drawn in the future adds up to 180 degrees. All right, and we just got this gizmo. All right, it's just a quick little picture. I'm not signed in, but you guys can click it and then it just shows this again. You can play around with it. It's really cool and a lot of fun. All right, so in the next video, we're gonna do some algebra. Stay tuned for more.